Today we're going to talk about functions. We've been talking about linear equations. Linear equations are functions, okay? Y equals mx plus b. But there are other kinds of equations that are functions, and we're going to talk about different ones. But I'm going to teach you the easiest way to look at a graph and know whether it's a function or not. And it's called the vertical line test, okay? So if I have a graph like this, and a graph like this, and a graph like this, you can use the vertical line test to determine whether these are functions or not. Two of them are functions, one of them is not. So the book says, and I'm on page 47, that a function is a relationship between the input and the output in a function, okay? There's only one output for every input. When they are talking about input and output, they're talking about x and y coordinates, okay? So the input would be the x, and the output would be y. And for functions, you can only have one output for each input. Now, I know that kind of like, what the heck does that mean? So I'm going to show you different ways to be able to see whether you have one output for every input. So if I were to put a line, a vertical line here on this graph, I'm going to do a dotted line for the purpose of the recording, but you can use your pencil, you can use a ruler, but if you see that vertical line, it only touches the graph in one place, one output, okay? If I do another one here, it only touches it there. So no matter, I could put a million lines on that line, vertical, and it never touched the graph in the same place, right? Okay, so this is a function. That's a function. Because you have a different output, a different y for every input, for every x. Okay? So if I do the same here, doesn't matter. Even though this kind of looks like it's going to be vertical eventually, it really isn't. It's going to continue to just a little bit grow out as it goes up. Okay? This is a quadratic equation. It's a parabola. That's what this kind of a shape of a graph is, a parabola. And it does not fail the vertical line test. It passes because it's only touching one point of the graph every time you do a vertical line test. So this is a function. Okay? So let's try this one. Well, here it's touching the graph in two places, right? So that means for every input, which would be an x, I'm having two y's. So for every input of an x, I'm getting this y and this y. So I'm having two outputs for one input. Okay, one x, two y's. Not a function. Okay, so vertical line test, even if, let's say, they give you a different way to show the graph. Let's say they give you an equation. Make a t-chart, graph it, do the vertical line test. If you forget everything else, you can always go back to that. If they give you a t-chart, you can look and see, and I'm going to show you that in a minute, that if you have two x's the same on the t-chart, it's not a function. So you can just look at the x's. If there's more than one x that's exactly the same, not a function. Okay? So let me go back here. So sometimes they give you what they call mapping, like this. And this is Some vocabulary here. This is your domain. And this is your range. So one of the things you need to remember that the domain are your x values. And your range are your y values. And the way you can always remember is D comes before R, ABC order, X comes before Y, ABC order. Okay, so that's an easy way to remember it. D is X, R is Y. Okay? So if we have, say my domain is 0, 3, 5, and 3. And then, or no, let me not do that. Hold on. 0, 3, 5, and 6. And then I have -1, 6, 8, 12. And I do this is called mapping. And you can see here that there is one y for every x, right? One x, one input for every y. But what if I did this? What if I did this? I would have, let's write the ordered pairs. I would have 0, -1. I'd have 3, -1. I'd have 3, 6, 5, 8, and 6, 12. Well, right here, I have two x's that are same with different y's, right? And they say that you can only have one output for every input. Now, you can have the same y, because what if I had a graph that's a horizontal line, and it's going through y equals 2? You do a vertical line test, it's only going to go through one part of that graph the whole way. So you can have all the same y's. I could do this if I wanted to. 0, 1, 2, 1, 3, 1, 4, 1. That's a function, because every x is different. Okay? But it's not a function if you have the same x's. That's when it's not a function. Okay? But like I said, you could graph it and look at it that way if you forget. Because I forget, but I'll go and graph it, and it's like, oh yeah, that's right. I always just graph this one, and then it reminds me, oh yeah, different y, same x, and I know that that graph doesn't pass the vertical line test. So that's my go-to to remember. What can I not have the same? I can't have the same x for two values of y. Okay? All right. So I want you to look at on page 47. Let's look at, first of all, their example with the mapping, the domain and range. Is that a function?
Yeah.
Yes, because why?
Because all the x is different.
Yeah, you have, and if you want to put it like the book puts it, that there's only one output for every input. There's only one x for every y. One output for every input. And but yes, you're exactly right. That's a function because there's only one. And it also says here which element of the domain is paired with exactly one element of the range. So we're good there. But if we had two arrows coming out of that -3, it'd be no, because I've got two x's going to two different places, and that is not a function. Okay? So if you look at the second example, we have a graph like this. Oops. And what some people worry about is if you do a vertical line test, it looks like this eventually gets to be vertical to the point it's going to touch the graph more than once, but it never does, okay? These kind of graphs will continue to grow in the direction that they're going. And they, even though it looks like, I mean, I think the one in the book is more like this, but it's still a very subtle change every time, so it will pass the vertical line test. Okay? Because you can see there that if you look at that graph, there's just a little bit of movement from on the x-axis. It doesn't actually end up vertical. Okay, so that is a function because it passes the vertical line test and there's only one x for every y. Okay? So if we look at A, is that a function? Example 1a on page 47. Yes, it's a function because every single x is going to a y. It's okay that you have a 0, 6 and a 3, 6. You have the arrows pointing to the same y, but every x is discrete. It's its own thing. It's not going to two y's. Okay? How about b? Is that a function?
No.
Why is it not a function?
Oh.
You have two what? It's two ones. Very good. So you have two domains that are one. They trick you because they don't put them in order. And that is not a function. How about on the guided practice number 1 on page 47 at the bottom? Is that a function?
No.
No, because you have two 2's and you have two 3's. Simple enough, right?
Yeah.
Okay, so we're going to go on to, and if you look at page 49 at the top, you'll see good examples of functions. The parabola is a function. That middle one is not a function, because if you do the vertical line test, you're going to go through two parts of the graph vertically. But look at the third one. That one's interesting. You only have one x on that y-axis, because one of them has the open circle. If both those circles were closed, it would not be a function, because you'd have two of the same x's. But since it's open, that one at the top is not going through the y-axis. It's right after the y-axis. Does that make sense? So it doesn't have the same x coordinate of 0 because the one on top is not going through 0 for x. All right, so at the bottom of the page, they're showing you 3 ways to show graphs. We have the t-chart, which you recognize. You've just seen what mapping is. And on that mapping, is that a function? Yes, because all of the x's are going to a different y. And then we have the equation, and we have a graph. Those are all ways to represent functions. Okay? So now I'm going to talk to you guys about function notation. So function notation, normally you guys are used to seeing y equals 3x minus 8. Right? That's your slope-intercept form, y equals mx plus b. But you are allowed to, especially because this is a function, right? Change the y to what we call f of x. They are interchangeable. They are interchangeable. Okay? So basically, y is dependent on what x is, right? You're going to get a different y for every x. That's what this is saying. Y is a function of x. Whatever x is going to determine what y is. It's dependent on what x is. Okay? So, you will get something like this. Example 4. F of x is equal to negative 4x plus 7, and they want you to find f of 2. What am I going to do with that 2? If I replace the x with 2, what will I do with that 2 in the equation? What will I replace? The x. Very good. So for f of 2, it's going to be negative 4 times 2 plus 7. Negative 8 plus 7, negative 1. So f of 2 is negative 1. And remember, the f of x is your y. So 2 is your x, negative 1 is your y. Yes. All right. So now we're going to talk about trying this problem, f of x equals 2x minus 3. And we're looking for f of negative 2. It's always a really good plan.
Can do it for my teacher.
Oh, cute. Thank you. All right, so we've got f of negative 2, and we are going to plug that in for x minus 3, which is negative 4, minus 3, which is negative 7, not negative 1. Many of you were putting negative 1. So that's your answer for f of negative 2. So you could say that negative 2, negative 7 is what you were looking for. Okay? So now, right, we have f of negative 1 plus f of 2, and we're going to use the same equation. Now you're going to do both of these problems separately. You're going to do your f of 1, negative 1 minus 3. And then you're going to do f of 2 and then you're going to do f of 1 plus f of 2 f of negative 1. And that's going to be negative 5 plus 1 is negative 4. Okay? So